these first equations here are going to be basic. You probably would have seen them in Algebra 2 last year. All right, so this first one. When we're solving these things, you see I have log equations, like because I have the word log, I have exponential functions. Sometimes you can just do them like with like your simple basic rules. Like look at this 25 and this 125. They're both powers of what? 5, right. And so sometimes you can just use your general knowledge, and hopefully maybe even if you were an Algebra 2 regular, you did one of these last year. 25 is really 5 to the 2, and the 3x minus 1 just sits out there. And 125 is really 5 to the 3rd, and then you got 5x. So I don't need to use any like tricks of like logs or do anything special. All right. What do I do to my exponents when I have it like this? Multiply, right. So I have 5 to the 6x minus 2, and over here I have 5 to the 15x. And so once I, remember this is an equation, so once I have parts that are equal, I can kind of like forget about them. Like what's already the same about both sides right now? The 5. So in a way, I just kind of like, okay, those are done. Technically, I'm kind of taking the log of both sides and getting rid of it, but you can just think they're just gone. So basically, I need 6x minus 2 to match 15x for it to continue, to be equal. So 6x minus 2 equals 15x. I just need to solve that. So what should I do to both sides then? Subtract 15x, or 6x. So I get 9x equals negative 2. So my answer would be negative 2/9. Okay? All right. All right, so sometimes it's like basic like that. All right, that says negative 2/9. All right, so in letter B, I can do kind of the same thing. Every single one of those parts is all powers of what? 2. So the 2 is already there. I'm just going to leave him alone. But the 8 is really 2 to the 3rd. So when I have that 2 to the 3rd, the 3 in this 3x will be 9x. Is that all right? Because I don't have to write it again. So 2 to the 9x. And 16 is 2 to the 4th. All right, so put that. So I have something I can do, but everything has to be put together first. So on the left side, if you have something with the same base and you're multiplying, what do you do to your exponents? You add them, right? So just like if you had x to the 4th times x to the 2nd, you'd be like, oh, that's x to the 6th. I'm supposed to add. So over here on the left, I have 2 to the 10x plus 1. Is that all right? Because 9x plus x plus 1. And 2 to the 4th. Okay, so just like before, I don't need the 2's anymore. They already equal each other. So I really need to know what x is, so I do 10x plus 1 equals 4. And I think we can just solve that in our head probably. So you get 3 over 10. All right, now, you're going to have to be careful in this stuff, in this section, and check your answers a little bit. But you do not have to check answers that start off with exponential functions or exponential equations. Like exponents can take anything. Like 3/10, you can put that in for x and the exponent and it's going to work. Like it's okay. But what I'm talking about is things like let's say right here. What if I solve this problem and I get like x equals 0 when I solve this? Well, that leaves me with ln of negative 4. Is that okay? No, that's like illegal. Or what if I get something like x equals like negative 3? Well, then that would be negative 3 minus 4, negative 7. And that would be bad also. So I have to make sure if there's a log in your problem that your answer is okay. So we're going to have to check them if they're logs, but exponent problems can handle anything. So we don't have to check them. Okay. All right, so letter C. So letter C, a lot of times with logs, the thing that you ultimately want to do is change them to an exponent because you can solve that. So this is base 4, I got my 2 over there, and 2x plus 5. So if I change this to exponent form, I would have 4 to the what? 4 to the 2 has to equal 2x plus 5, right? And then that's great because the log's gone. So you want to get rid of the log somehow. Either there's going to be a log on both sides and you drop it, kind of like we dropped the 5 in letter A, or you do it like this, change it to exponent form. All right, so we all know that that's 16 equals 2x plus 5. So what's my answer to that? 11 over 2. And it was a log problem, so just go ahead and like check it real quick. 11 over 2, could this log of 4 handle 11 over 2 right here? Yeah, it's not going to make it negative, so we're good. All right, now letter D. Letter D, I can do this one of 2 ways. What could this 3, where could he go if I wanted to? He could go in front. And then if once he's in front, I could divide him into the 6, right? And then do it that way. So we'll do that way in a second. So we'll split this into two problems. Let's just do it the normal way. Like let's say I didn't even notice that. What base log is this? 10. So I would say to myself, this is 10 to the 6th. So 10 to the 6th, that's 1 million, has to equal what number? Or what part? Or what thing? Right, 2x plus 7 to the 3rd. Okay, that's fine. You don't have to write a million because let's say you don't have your calculator around. But how do you get rid of a third power? You do the, not square root, the cube root. So I'm going to do the cube root. Well, a cube root is like a fraction. What kind of fraction is a cube root? 1/3. So you can write cube root over here, but ultimately you want to say to yourself, well, that's 10 to the 6th and then a 1/3 power, right? And over on the right side, the 2x plus 7 pops out. All right, so what do I do with that 6 and that 1/3? Multiply. So this would be 10 to the 2nd power. But what is 10 to the 2nd power? 100. So I didn't have to use my calculator. I was able to like noodle through all the exponent work. So this is going to be 100 equals 2x plus 7. And I bet we can get the answer without doing any more work. 93 over 2? Okay. So that's one way you could do it. So the other way you could do it is this. At the initial step, that 3 can go out front right here. And so when I would have 3, and then log base 10 of 2x plus 7, so now it's much simpler, equaling 6, you could divide the 3 out. And so that would get me a 2 on the other side. So log base 10 of 2x plus 7 equals 2. So now I write it as an exponent. 10 to the 2 equals 2x plus 7. Well, what's 10 to the 2? 100. So 100 equals 2x plus 7. And then, you get your 93 over 2. Okay? So that's all fine. You can do that, but you have to be careful. If this is an odd exponent, that 3 right there is odd, you are only allowed to do this if it's odd. Because watch what would happen. I'm just going to like make one up randomly. Let me get out of here. If it was even, watch what might happen. If you had the log, and I'll just put like base 4, how about? And you had x plus 7 squared equals 2, like that. All right? So if I go to solve this problem the normal way, I'd be like, oh, 4 squared equals x plus 7 squared. Everybody with me? Oh, so 16 equals x plus 7 squared. What am I supposed to do now to solve? Square root. I'm supposed to be like, oh, square root, square root. So when you do a square root, what happens to your 16? You get a plus or minus 4, and then it's x plus 7. So do you see, because it was a square, you're going to get 2 answers? All right? Cubes don't have 2 answers. They just have one cube root of something. But a square produces a plus minus, so that means my answer is really -7 plus or minus 4. So like 2 answers. So you be careful. If the problem is written, if that 2 is already out there, then fine, get rid of it. But if this 2 is up here, when you move it, you're not allowed because you're going to lose one of your answers. So my answers here would have been -7 plus 4, -3, or -11. So watch if I had moved the 2. If I move the 2 down, I get log base 4 of x plus 7 equals 2. What would you do with the 2 now? Divide it. So you'd have log base 4 of x plus 7 equals 1. And so you'd be like, oh, 4 to the 1 equals x plus 7. You would never know there was 2 answers, right? And so you would have only gotten x equals -3. You've only gotten one of your answers. All right? So that happens with even powers, not odd ones. Yes? So, because you're wondering if they're both okay, right? Well, let's check it. If I put -3 in here, that gets me 4 squared, which I can do, the log of 4. If you put -11 here, you're thinking that's bad because that would turn into -4, but you're squaring it anyway. So it's going to turn positive anyway. So these are both answers. Like if you graph this equation, these 2 and that equation, they cross like twice. They cross once here and once there. They cross twice, and so there's 2 answers. So you just have to be careful. If it's an even number, don't touch it. Okay. All right. Okay, so it's going to be lunch in a minute, so we'll stop and come back. All right, so here we go. So where were we? Let's see. Okay, so this letter E is a little bit strange, but it's still, these are just examples of like all different things that you could do. So, like, like letter E, that one's kind of annoying. I won't put that on a test, but, you can still use these type of things. Anyway, so this time I have a problem because, well, first of all, what base is this? 10. All right. And I have an issue because I can't really, that 3x minus 1 is in the exponent, and it's just a single. It's a single x. It's not x squared, so I don't have to worry about anything like that. But what I'm going to do is bring the 3x minus 1 to the front. Okay. So it's an exponent of the 8, so I'm allowed to bring 3x minus 1 to the front, as a whole. And then what would I be left with after it? Just log of 8, right? Log base 10 of 8. So log of 8 equals 4. So remember, log of 8, this is like a number, right? And so now I could just, would you like to multiply log of 8 by 3x minus 1? Or would you rather divide it out and get rid of it? Yeah, let's get rid of it, right? Because like a decimal times these numbers, that's going to be just gross. Why don't I just get rid of it so I can just get 3x minus 1 alone? And then on your calculator, you're just going to need log of 8 divided by 4, right? Oops. So you do that for me. Yeah, so log of 8, you just get that answer and divide it by 4. So that way we got, 0.226, let's say. What's wrong? Did I do something wrong? Oh, haha, thank you. You're right. 4 divided by log of 8. Duh. Sorry. You're right. 4.43. Is that good? Everybody good? So log of 8 right here, this piece, it's just a number, right? I just want to get rid of it so I can solve the 3x minus 1 part. So I'm just going to like divide it over here. So 4 divided by log of 8, because log of 8 is just like, 2 point whatever or something. So, or it's not 2 point whatever, but you get my intent. All right, so what was that number we had? 4 point something? All right, so now I just have to add 1 and divide by 3. So just do that in your calculator. You add 1, you get 5.43. Divide by 3, you get 1 point something. Thank you. So that's unusual. It's kind of weird, and I had to use my calculator, but that's fine. It's just how it is. All right, so for letter F, so finally you have one with natural log. So remember, natural log has a base what? E. So you can remember that's a little e down here, or you could write, usually you're supposed to write log base e. That's what ln stands for, is log base e, so you can write it shorter. So there's nothing I can do here other than write it as an exponent. My base is e, so I'll write e to the 5th equals what? X minus 4. So if I didn't have my calculator around, my answer would just be x equals e to the 5th plus 4. I'll just tell you that that's what it is. That 4 is a big 4. It's not like with the 5, right? I wrote that kind of weird looking. So it's e to the 5th, and then that answer plus 4, right? So if you want, if you were able to use your calculator, then you would just type that in and get your answer. So what'd you get? Okay, so that's it. Everybody fine? All right, so now you're going to get a bunch of problems with more than one log. So we'll take a little break after these 4, then we'll take a little break for a couple minutes just to let everybody kind of like, I don't know, it could be too much. Actually, maybe these 4 and there's 2 more on the next page. So, because we just had lunch, I guess, right? All right, so these have more than one log sometimes, or they're just harder, okay? So there can be 2 scenarios that you have to do. If you just have, if you have a number, so if you have logs, and you have a number in your problem. If you have logs and you have a number, like which of these problems have logs and a number, like a plain number? Example 1 does, and also example 3. Example 2 has all logs. Okay, example 3, I got this 2 right here, and example 4, I have the 10. So I'm talking about what I'm about to say, I'm talking about these 3 right here. All right, there's logs, but there's also numbers. What you're going to want to do is you're going to want to get your log expression equal to a number. So you want to separate your logs and your numbers, and then we're just going to write them as exponents and solve it that way. Okay. The other things situation you're going to have is like example 2, when you have logs everywhere. So you have all logs. Okay, everything's a log. So then we are going to just condense what we can, and we're going to drop the log. So after we condense it, then we'll have a log equal to a log, and then we're just going to like drop the word log and solve whatever was left. Okay, kind of like on the last page when I had something like this. Once I got it to here, I dropped the 2 and just solved the other part. Okay, all right. So now example 1. So I have to get this log cleaned up. I got to take away 6 and get rid of the 3. So can I just skip to this? Log base 2 of x squared minus 5 would equal what? Because if you clean it up, you'd have to subtract 6 and divide by 3. What would you get? 4, right? Because you take away 6, you get 12. 12 divided by 3 is 4. All right, so I'll save you some writing. Okay, now you're ready to write it as an exponent. Okay, my base is 2, so it's 2 to the what? 2 to the 4th. So what is 2 to the 4th? 16. So why don't I just write 16 has to equal what expression? Right, x squared minus 5. Okay, so then I just have to solve that. So add 5 to both sides, I get 21 equals x squared. So x would be radical 21. Anything else? And that's plus or minus. All right, so just be careful. This did have a log in it. Go back and think about, especially when you had a negative here. If you put a negative radical 21, like back in your log part, it's squared, so it would turn positive. And is 21 minus 5 going to be okay? Yeah, it's positive, so we're fine. So just logs, you have to check. If you get a negative answer, you gotta want to check it. Just make sure it would still be okay. All right, so there you go. Okay, let's go on to example 2. Example 2, I have all logs. They're natural logs, but so what? They're all matched. All right, so what can I do with these two? Can you mush them together? Yeah, right? Addition turns into multiplication. So pretty much you don't usually want to expand logs. Usually what you do is you have a bunch of logs and you put them together when you're solving equations. So I have that this is ln of x plus 2 times 3x minus 2. So you might have done this last year, but your problems didn't turn this difficult. So over here, what can I do with that 2 in front? As an exponent, right? He's an exponent up here to this 2x, right? So now it's going to be ln of 4x squared. Okay. So now I have a log equal to a log. It's the same problem. These things already match. So what I can do is I'm just going to drop them off, and I'm going to keep this part, and I'm going to say it's equal to that part. Because, you know, it's an equation. Like, equal parts have to equal each other. All right. So my x plus 2 times 3x minus 2 has to equal 4x squared. So I got a quadratic that I got to solve. So we're going to multiply out the left side. X times 3x gives me 3x squared. The outside is negative 2x. The inside is positive 6. So what's the middle going to be? Right, positive 4x and then minus 4. All right, so if I'm going to factor, now I'm not going to give you ones that you need the quadratic formula for. That would be too mean. These are all going to factor. But if I'm planning to factor, do you want to bring everything to the right or bring the 4 to the left? Yeah, even though it seems more work, I want the x squared to stay positive, and I don't want to have to mess with it anymore. So I'm going to take away 3x squared, so I get x squared. My 4x turns to a negative 4x, and my negative 4 turns into a positive 4. Okay, so when I factor that, I got x and x, and what multiplies to 4 but also adds up to 4? Yeah, both of them minus 2. All right, so the only answer I have to report, you know, sometimes I would think I was going to have 2 answers here, but I only have positive 2 to report. So this was a log problem, so just go back and check. If you put a 2, like right here, would that make a negative number that you're taking the log of? No. If you put a 2 here, it would be 6 minus 2. That's fine. If you put a 2 here, that would be fine. If my answer had been like negative 2, I would have not kept it. I would have been like, no, I can't. There's be no answer at all. Okay. All right. So number 3. What situation do you have? Do you have a number or do you have all logs? All logs but this guy. So it's important to see that guy right there. He's not with the 12x. He's after. If I wanted that to be log base 12 of 12x minus 2, I would have to put parentheses around it, right? So there's not. So that 2 is separate from him. All right. So I'm going to get the logs together, put the 2 on the other side, so that I can pretty much do what I did up here. Okay. So I'll have log base 12 of 12x. If I bring this guy to the other side, he'll turn into a plus log base 12 of x minus 1. But put the 2 on the other side, get 2. Is that all right? Okay. All right, so I'm going to put them together. Addition turns into multiplication. So I got log base 12, and I got 12x times x minus 1 equals 2. So now I'm ready to write this as an exponent. All right, so I have 12 squared equals what's inside the log. So what is 12 squared? 144. So I got 144 equals 12x times x minus 1. Now, I could multiply the 12x out, but do you notice something I could do to make my life easier? Yeah, divide by 12, right? I mean, there's a multiplier of 12 on the right side, and 12 goes into 144. So why don't I just divide by 12 to make everything a little easier? So I get 12 equals x times x minus 1. I mean, I still got to multiply it out and factor, but at least it's smaller. Okay. All right, so on the right side, I got x squared minus x. That 12 is going to have to come over with me. So what's he going to turn into? Minus 12 behind there. Okay, and so I got to factor what multiplies to 12 but also makes 1 in the middle. Right, negative 4 and positive 3, right? This adds up to negative 1. All right, so now I might have a problem. My answers are 4 and negative 3. So I have to go back and think. If you put a 4 in the original, don't do it to anything that you fix. If you put a 4 there and a 4 or a 4 there, would that cause a problem? No, because it'd be positives, right? But if you put a negative 3 here or here, yeah, you can't do that. So just cross him off. He's an extraneous solution. Okay. All right, so example 4. It looks like you got a choice. This is log base 10. Would you rather take this negative 5 and bring it up here and multiply by the 2? Or would you rather just like divide it out? Right. Yeah, you want to have a 10th power thing to solve? No, right? So why don't we just divide the negative 5 to the other side, right? So let's get rid of it that way. Divide both sides by negative 5. That'd be a lot better. So I have log, and when I write base 10 of x plus 7 squared equals negative 2. All right, so like I said before, this x plus 7 squared. I don't want to bring that squared out front because I would lose one of my answers because I wouldn't recognize to put a plus or minus on my square root. So I'm just going to leave it like that, even though it's kind of, it'd be annoying, but I have to. So I'm going to write 10 to the what power? Negative 2 equals x plus 7 squared. All right, so 10 to the negative 2. 10 squared is 100, so what's 10 to the negative 2? Yeah, or 100th, right? Or 0.01. All right, so I'm going to write 100th, so it's a little bit easier for us in a second. So what you have to do to both sides? Square root. So square root, square root. I left it as 100th, so what's the square root of 100th? 1/10. So 1/10, and the x plus 7 comes out. And what did I forget? Plus or minus. All right, so all I gotta do is take away 7. So a lot of times it's easier to just do this. You're gonna pop the 7 on the other side in front of these guys. So you're gonna say it's negative 7 plus or minus. And why don't I write 1/10 as a decimal so it's easier for me to do? So 0.1. All right, so here's my answers. I got negative 7 plus 0.1, so I get negative 6.9. And I get negative 7 minus 0.1, so I get negative 7.1. So you just have to go and think about it. This is a log problem, so let's think about it. If you put a negative 6.9 here, or if you put a negative 7.1 there, the reason I don't care is because what do I see is happening to that expression every time? And squaring it. So you can put anything you want there. I'll just square it, and my problems will be gone. Okay, so these are both okay. All right, let's do the last two in this little section, and then we will take a break for a second. All right. What's your plan for me on example 5? What do you want to do? Condense, right. Put these two together. So I got log base 3. I got to multiply 2 times 2x plus 1 to the third. So I'm going to put the 2 in front, because usually the little numbers go in front. 2x plus 1 to the third. Now, let me ask you this. This 3 out here, it would be okay for me to put that 3 there, but then I couldn't have condensed. Do you follow? Like, I don't want to put that 3 out there because it's not going to help me, and then I have to put these together anyway. So, you don't always want to use all the rules that you know. All right, so this equals 4. All right, so it's 1 log equal to a number. I'm ready to just like write it as a what? Exponent, right? So it's 3 to the what power? Okay, so 3 to the 4th. What is 3 to the 4th? So it's 9 times 9, 81. So I got 81 equals 2x plus 1 all to the third. Okay, I got a third power. Got to get rid of it, so I take the... Oh, you're right. I lost my 2. Thank you. So there's a 2 there. You're right. So I can't do the third root yet because I have to divide the 2 out. All right, so divide the 2 out. Thank you. So I got 40.5. All right, so 40.5 equals 2x plus 1 to the third. So I'm going to have to take the cube root. All right, so cube root. Do you put plus or minus when you put cube root? Nope. All right, so let's see. I'm going to go right. So I have 2x plus 1 equals the cube root of 40.5. All right, so let's just like treat this like we don't have our calculator with us. What 2 steps am I going to do to like solve for x? I subtract 1, and I'm going to divide by 2. So when I just write that, I have the cube root of 40.5. I'm going to take away 1 from it, and I'm going to divide it all by 2. So if I didn't have my calculator, I could write that. But since I do have my calculator, I can type it in. I got my fraction. I got my cube root of what, 40.5 minus 1 over 2. Okay, so 1.22. Or you can just leave it like this. I don't care. All right, last one. Then we'll take a little break. So finally, I got some subtraction. I have logs everywhere, so I'm just going to leave this guy over here, and I'll just condense to their side. So subtraction turns into division. All right, so I got ln of 2x squared plus 4 all over 3x. So I dropped the parentheses because I didn't need them anymore, because now that I was putting the grouping symbol, the division, those are held together. Equals ln of 3. Okay, so what can I do to my ln's? Yeah, kind of drop them and say 2x squared plus 4 over 3x has to equal 3. So we'll just like cross multiply, 3x times 3. So I get 2x squared plus 4 equals 9x. So I have 2x squared. I'm going to bring my 9x over. Minus 9x plus 4 equals 0. All right. So what's your suggestion on trying to factor? 2x and x. Now, what's the one thing that makes 4 that I'm never going to even be able to use? 2 and 2. Because you can't put a 2 here, can you? So I had to go with 4 and 1. Where does the 4 go? In the back, because you can't put 4 here because of the same reason, because 2 goes into 4. So 4 here, 1 there. Let's check. I got 8x and not a 1 makes 9, so everything's negative. All right, so here's my 2 answers, 1/2 and also 4. This was a log problem, so you go back and mentally kind of check it. If you put a 1/2 or a 4 there, is it going to be a problem? No, it's positive, it's fine. If you put a 1/2 or a 4 there, any problems? No. So you're good. All right, take a break for a couple minutes. All right, our last few examples here. So you notice in example 1, so these are exponential equations. Back on the first thing that we did, you had some exponential equations like this one here, but you were able to like relate the bases to each other. Like 125 and 25 are both powers of 5, or letter B over here, 2, 8, and 16 were all powers of 2. So there's sometimes a problem where you just can't, like there's nothing to do. So that's like example 1 here. You have 5 to the 3x equals 12, and 12 is not a power of 5, and 5 is just, you can't do anything with that. All right, so you have a choice. You can do it this way if you like, but you'll never see me do it this way because it irritates me, and I'll just do it the second way I show you. All right, so if you want to, when you get an expression like this, you could turn it back into a log. Like, logs are yucky, I don't like it. But all right, so watch. So if I wrote this as a log, I would write log base what? What's the base here? Yeah, 5. 5 is acting as a base to 3x, right? So log base 5 of 12 equals 3x. You see that? 5 to the 3x equals 12. Yeah? So if you want to, I mean, I'm going to have to use a calculator anyway eventually, but I just don't do well with this in myself. And so you can put that in the calculator and then divide it by 3. So if you like that, go ahead. I don't care. But I like to do it this way. So I think that way is kind of poo-poo. All right, so when I have 5 to the 3x equals 12, and I can't do anything else, I can't get to something in the exponent unless there might be the word log in front of it. If there was the word log in front of this 5, then that 3x would be allowed to come to the front of it, and it would be like on the level where I could like touch it and like do stuff to it, right? So you can take any log of both sides. You know, like when you solve an equation, if you add something to both sides, as long as you do it to both sides, it's fine. If you take the square root, do it to both sides, it's fine. So I'm allowed to take the log of both sides as long as it's the same log and I do it to both sides. So the easiest log to write is log base 10 or ln. ln. So I'm just going to do ln here and ln there. Okay? So I'm creating that. That's fine. We're like putting that in there, but it's okay because we're doing it to both sides. And now that I have an ln there, the 3x can come to the front, and I have ln 5. Is that okay? Other side is ln 12. All right. So at this point, ln 5 and ln 12, those are just numbers, like some random decimals, right? So I would like to just like divide the ln 5 out, and I'll have 3x. Oh, actually, well, I'm trying to solve for x when I do it all at once. What's next to the x that I need to get rid of? 3 and ln 5. So why don't we just divide by both of them at the same time? So when I divide by them, I'm going to have ln 12 over here. On the other side, what's going to both be on the bottom? 3 and ln 5. Okay. So you leave it like that, or type it in your calculator. So make yourself a fraction and type it in. So what is it? ln 12. All right, so 0.515. All good? Yes. Yeah, so like on your test, I'll give you a part where you don't use your calculator at first, but in these questions, you have to. Like, yeah. So, okay, you saw maybe like on some of those other questions earlier, I didn't really need it because it was all things that I knew, but. All right, so same thing with example 2. I don't know, but I'm going to go right here and take the ln of both sides, ln of both sides. So what I have then on the left side is the x plus 5 can come to the front, and then I have ln e next to it equals ln 20. Well, this one's super nice. It says, what's ln e do? Yeah, I don't have to deal with it. This whole ln e part right here, that just goes away to 1. And so I get x plus 5 equals ln of 20. And then all I have to do is subtract 5. So I'm going to go down here. So x equals ln 20, and then take away 5. Now be careful, that ln 20, you got to close your parentheses around the 20 before you subtract 5, right? But, you put that in your calculator. So could somebody put it in for us, because I don't want to do it. No. -2. Okay. 0.004. Okay. All right. So the next ones are just going to be kind of like a combination of all these things, but maybe there's some more cleaning up to do. So my goal on this next part, I need to get this 2 to the 5x. I need to get it alone so I can do this ln business, right? So what 2 steps do I have to take to get it alone? Get rid of the 6, and then get rid of the 4. So I'm going to add 6 to 18, get me 24. Then 24 divided by 4 would be 6. So if I cleaned it up, I would have 2 to the 5x equals 6. Everybody good? Is 6 a power of 2? No. So I'm stuck. So do my ln. ln. All right. So I have 5x out front. I have ln 2, which is just some number, equals ln 6. All right. So I need to solve for x. What's over here bothering my x? Like it's in the way. The 5 and the ln 2. So I just have to divide them away. So ln 6 over 5 and ln 2. And if you needed a decimal, you put in your calculator. All right. So for number 4, what's bothering you, you got to get rid of? Then -6. So I have a problem also. If this thing doesn't turn positive, I can't take the ln of both sides either. But when I divide by -6, I get 7, right? So I have 20 to the 7 minus 3x equals 7. All right. So this one's just a little bit more annoying because the exponent's a little bit more annoying. Okay. So I'm going to take the natural log of both sides. So ln here, ln there. So when I bring the 7 minus 3x to the front, it's going to have to stay like contained. And what do I have next to it? ln 20, right? Equals ln 7. So you have a choice. Would you like to take ln 20 and multiply it through to the 7 minus 3x? Well, that's gross. Why not just divide it to the other side right now? Okay, so I'm going to divide this over here. So I just have 7 minus 3x equals, tell me a decimal for ln 7 divided by ln 20. Yeah, so ln 7 divided by ln 20. All right, so then, why don't we keep this in our calculator and we'll just get the answer. I mean, I'll write that down in a second. When you have this number over on the right, what 2 steps are you going to do to it to like solve? You're going to subtract 7, right? So why don't we just keep it and subtract 7. And then you're going to divide by -3. So divided by -3. And that way you don't lose any decimals, and there's my nice best answer I can get. So 2.12. So my final answer is 2.12. And the answer when I divided was 0.65. Okay? All right, yeah, last 2 problems. You're not going to like the very last one, but well, the next to last one isn't that good either. All right, so here this is really super annoying because 4 has nothing to do with 3. I have exponents in both of them, so I'm just going to have to go and take the natural log of both sides, okay? And those exponents come down. So I got 3x minus 1 coming down, and I have ln 4. And then I have 2 minus x coming down, and I have ln 3 next to it. Is that okay? And this pen is not writing in the right place, so. Now, I kind of am at a loss as to, like, I can't like separate those nasty fractions from anything. If I wanted to, I could like divide these to get one nasty number, but I don't know. Why don't we just get rid of them right now? Tell me ln 4. What's ln 4 on your calculator? 1.29? 1.3? All right. All right, so we're just going to say this guy is 1.3. All right, what's ln 3? 1.2? All right, we're going to say this guy is 1.2. Huh, what? 1.1, all right. So let's just use those numbers and, you know, it won't be perfect. So 1.3 times 3, that gives me 3.9x minus 1.3. And then 1.1 times all this, 1.1 times 2 is 2.2 minus 1.1x. So I just have some gross answers. All right, so I'm going to add 1.1x to this guy, so that gives me 5x. Another side, that gets me 3.5. Yeah, add this. All right, so it's not very perfect, remember, because we knocked off a lot of decimals, but 3.5 divided by 5 would be my answer. What's that? 0.7? Okay. All right. For this very last problem, I need you to get your factoring hats on a little bit. Also, if I write e to the x and I square it, what does that give me? E to the 2x, right? So I want you to see this. This right here, that's just e to the x squared, right? Okay, so I need to bring this 16. So this is a quadratic, and you don't recognize it, but let me show you. So e to the 2x plus 6 e to the x minus 16 equals 0. So this is e to the x being squared. The next part is 6, and then I have my e to the x, right? And then I have minus 16 equals 0. You see that? So it's kind of like I have this. I have something squared plus 6 times that something, you see it? Minus 16 equals 0. All right, can you factor this thing in red? What does the red thing factor to? 8 and 2, right? So plus 8 minus 2. All right. So if you can take this and put it back to something you understand, then you're like, oh, what was this e to the x standing for all along? I mean, what was this x standing for? E to the x. That was just e to the x. That was just e to the x. All right. So that's how you factor it. You take it back to something you kind of understand, and you're like, oh. So when I factor this, it's e to the x, because e to the x times e to the x makes e to the 2x. I need a plus 8 and a minus 2. Okay. All right. And then remember, back in algebra, you know, when you got these answers, didn't you go and say, oh, x equals 2 and x equals negative 8? You finished it? So that's what we got to do. So I get e to the x plus 8 equals 0, and I get e to the x minus 2 equals 0. So on the left, I get e to the x equals negative 8, and over here I get e to the x equals 2. Which one of these will I not be able to solve? Negative. So to solve these, I would say to myself, let me go ahead and take the ln of both sides. But can you take the ln of negative 8? No. So he's dead. But over here, ln, ln. So ln and e do what to each other? Cancel out. So I get x equals ln 2. That's the only answer I have. All right. I put the star up here to remind me. I just want to show you one last thing. If you got a question like this, you don't want to solve something with fractions. Could I multiply by something? You don't have to write it down, but just to see. Could I multiply by something to cancel all these fractions out? Can I multiply by e to the x? Is that all right? So e to the x times e to the x becomes e to the, or 2x, right? This becomes 12, and this becomes minus 8 e to the x. So if somebody gives it to you in that format, once you multiply it through, all you have is e to the 2x minus 8 e to the x plus 12. All you have is a quadratic, but you had to fix it a little bit. And so say to yourself, what multiplies a 12 and makes 8? 6 and 2. So when I factor this, it's e to the x minus 6, e to the x minus 2, and I would just go solve it like we did on the last page. Okay. So just be careful. I try to trick you with that, but it's really just like the last problem. Okay. All right, that's it.